This video is going to show you how to calculate the acceleration of Physlet. Our first method is going to rely on the fact that we're going to know the initial velocity of an object. If we know the initial velocity of an object, we can use x equals x naught plus v naught t plus 1/2 at squared. Because remember, in a Physlet, when you click the mouse, you can always find its position. And of course, the time always ticks off in the top left-hand corner, somewhere on the animation itself. Our second method involves the definition of acceleration. Acceleration is defined as the change in velocity over time. That actually becomes our VOAT formula that we've memorized. And so what we're going to do is we're going to find two different velocities and the time between them. And then we'll use this formula to find the acceleration, this definition. So here in this little animation, I've got these ghosting images that are going to appear. And they're going to define our time intervals. So we're going to define our time intervals to be 3 seconds and 6 seconds, and then 10 seconds and 12 seconds. Remember, the average velocity in this time interval is equal to the exact instantaneous velocity midway through the time on the time interval. So whatever the average is between 3 and 6, that average is the exact velocity at 4.5 seconds. Between 10 and 12, that average is the exact velocity at 11 seconds. So here's the way it kind of looks if you freeze everything, stop it from moving. I've got my first interval from 3 to 6 seconds, and I've marked my halfway midpoint in time, not distance. See, the distances aren't equal. This is about time. So 3 and 6 seconds, halfway is 4.5 seconds. So I know at 4.5 seconds, whatever the average is between 3 and 6, it's that exact velocity at 4.5. So in this case, at 4.5 seconds, it's 5 meters per second. Now, 5 meters per second is just an average velocity that I made up because I don't have all the numbers showing on the screen. In the next interval, I picked the second interval, and I've picked these intervals kind of randomly. I didn't really have a method to them. I just wanted to pick different intervals, different lengths to show you how it works. So at my second interval, I know that whatever my average is between 10 and 12 seconds, it's that exact velocity halfway through the time. So at 11 seconds, whatever my average is between 10 and 12, that's the exact speed. And so I've got a velocity of 15. Again, this example is just kind of made up because I'm not showing you all the numbers. So at this point, I'm doing pretty good. I've got two velocities. I've got my initial velocity at 5 meters per second, and I've got a final velocity at 15 meters per second, and I also know my change in time. It's my 11 seconds minus 4.5 seconds, those midpoints, the differences. And then I'm looking for the acceleration. So the formula that we're using, we're saying acceleration is defined as the change in velocity over the change in time. So that's going to be the final velocity minus the initial velocity over delta t. So that's 15 meters per second minus 5 meters per second divided by 6.5 seconds. Show a little bit of math, and I get my final acceleration to be 1.54 meters per second squared.